All right. Hello, everybody. Welcome to Intro to Git and Github. And moreover, welcome to Hack the North. This is Gear Up, a 5-day series of workshops, tech talks, and fireside chats with some of the coolest people in the world. I'm so pumped to be your host for the next about hour. We'll have some time for Q&A at the very end, so we might draw over to about 15 minutes, but we're good to go. Let's go ahead and get started. I'll skip the small talk. We don't have too much time. This talk is going to be divided into 4 really big sections. We'll start off by talking about why Git and GitHub exist in the first place, the problems that they solve, and exactly what they are. After that, we'll dive into some more abstract Git concepts, all while tagging along in the terminal. We'll actually be setting up our very own Git repositories, tagging along with a couple of commits, and using the basics of the shell to really navigate the core concepts of what Git does. After all of that, we'll use our newfound Git skills to tie it all back to GitHub and figure out the true paradigm for what software engineering looks like in 2021. And after all of that, after we've really gotten acquainted with the 2 biggest tools in software engineering right now, we'll start to create some of our first real contributions to a real-world project. We'll be putting it all together into something called an open source overlay. There's a couple of prerequisites that this workshop needs. You'll need a GitHub account, preferably with the student development pack, but that's optional. You'll also need a terminal with Git installed, and you'll also need some form of a text editor. Me personally, I like Vim and VS Code, but as always, you're free to use whatever you want. Just make sure that you have these 3 things prepared. The Hack Pack also has some pretty great resources that you can use to dive in afterwards. And if you're having any trouble setting up, feel free to put something in Slido or in some of the comments. And after all of that, it's time for me to introduce myself. I'm Rishi, like I said before. I'm 15 years old and I'm a junior at Turner Fenn Secondary School. I am in love with Formula 1, TypeScript, GraphQL, and Rust, and I'm a huge blockchain nerd. If you're into Ethereum or Cosmos SDK, feel free to hit me up on Discord. I can't wait to talk to you guys. I've been programming for about 8 years now, and I've always been incredibly interested in the world of open source. I've racked up thousands of different contributions to projects like Exorcism and Gun.js. It's really changed the way that I've interacted with myself and others as developers. And I really think that Git and GitHub are pivotal to the way that we write code right now. And all that being said, let's start figuring out what the heck Git even is. I'd like to begin by talking about a problem that most of us have probably faced. How do we share code? Well, let's say that you're creating a project. Nothing super interesting, mostly just a node web server. You have one file, one project that you really need to have set up. You have all of your server infrastructure already. The only thing that you need to do is edit this code, right? You want to write some features. So in the beginning, this works out to be pretty easy. You have one file located on your computer that you constantly need to edit and save. And the only thing that you really need to do is keep doing this all over and over again in one cycle, right? It's really simple because everything is centralized. You don't need to share it with anybody else. It's one file. The only thing you need to do is open this thingy up in VS Code and hit Control-S. But what happens when you aren't the only person on your team? What happens if in a hackathon, let's say, you have an interesting project that you might want to collaborate on with other people? How do you get this index.js file over to another computer? Well, if you have a Mac, you might use AirDrop. You might spread it on Google Drive. You might do any number of different things. But if you guys want to collaborate, you might use something like this. You might move your index.js file to a USB, then pass that USB to your teammate. They might edit it, pass it back and forth, and over and over and over again. And this index.js is used by the USB as the sole source of truth, right? As both of you start to collaborate on this exact same file, you lose track of every single other version. You constantly overwrite each other's changes, and you always have the latest version of your project present. What happens when you want to keep track of other versions? It might start off pretty simple. You have one centralized source of truth that you really want to interact with, which is your index.js file. But as time goes on, as you start to have more and more versions, as you start to release more and more features, you might end up with something like this. You have to create a bunch of different duplicates of files. You end up with index 1, index 2, index 3, index 4 million. Right? You constantly need to make changes to the exact same files, but you don't want to lose the very first copy of your code. What do we do now? And that isn't it. We're only keeping track of one file across two different team members. What happens if you're working in a Go project, which might have dozens of different files? What happens if you're working in a C++ project with hundreds or hundreds of thousands of different files? What happens if your team isn't just one or two people, but what if it's four? What if it's dozens? What if it's hundreds? What if you're working in a massive company and you have thousands of different employees? All of this are pretty common problems that software engineers face in their day-to-day lives. Luckily, the community has created some pretty amazing tools to help solve this, and that's exactly what we're here to show you. This is what Git and GitHub are really about. Git is what's known as a version control system. It tracks changes in a project over time. It's snapshot-based. This means that it can capture files and their changes over time in pieces and snapshots known as Git commits. Git was also created alongside single computer version control system features. Git allows you to collaborate with others seamlessly. And Git is the most used open source project of all time. It forms the core of modern software engineering. Git is the one thing that developers around the world use to collaborate and work on each other's code. Don't worry if all of this seems a little bit abstract right now. It's meant to be like that. We're going over some of the key concepts at a really high level. If Git is that, then what's GitHub? GitHub is the online space to host code and Git repositories. If you have a project, you can put it up online to GitHub for every other developer to see, interact with, and work on. GitHub was the very first large-scale Git provider and hosts the largest community of developers worldwide at over 50 million. GitHub also includes tooling for development productivity. We'll dive into that into the third chapter of today's workshop. And finally, GitHub has historically been the default tool for large-scale development. If you have a massive project, if you have a massive team, like I said before, if you have a company with thousands of different employees, chances are you might be using GitHub on a daily basis. And so going back to that one key idea of solving the USB conundrum, figuring out how you can share one file or one project across a bunch of different team members, this is what the Git workflow looks like. Instead of storing a project on a USB and passing it around a bunch of people, you can store your project on GitHub. Every single one of your developers on your team can connect to GitHub using the Git client. You can use the code that's stored on GitHub, pull it down into your own local directory, move around with it, and use Git to push it back up again for everybody else to use. In essence, Git and GitHub allow you to seamlessly collaborate across as many team members as you want. Before we continue, I wanted to take a super quick little question break. If you haven't done so already, make sure you have those three things prepared. We're going to be diving into some pretty hands-on stuff right now. And as always, if you have any questions, feel free to put them in Slido. I'll be back in about 1.5 minutes. All right, sweet. Let's go ahead and get back to it. Right now, we're going to create your very first repository with Git. As I said before, make sure you get your GitHub account prepared, your terminal with Git installed, and your text editor open. Before I do that, though, let's rehash some of the fundamentals behind what Git actually does. Like I said before, great software is built with multiple people. Even in this hackathon, chances are you're not going at it alone. You might have maybe 4 different people working on the exact same idea. Keeping track of changes is really important for all of this to happen. You can't constantly just be stamping on the exact same different file. Now, to efficiently keep track of all of the different changes in a specific project, all of this is done using version control system software. The most popular being Git. GitHub is a hosted social provider for Git that allows others to contribute and that hosts code. No problem, Arham. Go ahead and check out the hack pack. Make sure you have a text editor open, a terminal with Git installed, and a GitHub account ready to go. Let's go ahead and get started. I'm going to switch on over to my terminal real quick. All right, sweet. It doesn't matter which directory you do this in, as long as it's constantly accessible to you. If you want to go over to your home directory, go ahead and type in cd tilde. I'm going to be working out of a custom directory that I've created earlier. Now, as soon as it's done, let's go ahead and move back over to the Figma instructions. Go ahead and create a folder. You can name it whatever you want. What's the default editor to be used while installing Git? You can use whichever one you want. As long as you have the directory path that you're working with a project with, you're good to go. Just make sure you can open a folder in whatever text editor you're using. I'm using Vim personally. I'm gonna go ahead and create my project. Let's name this Hello World, and let's cd into that directory. Now, as soon as you run git init in whichever directory you're using, you should get a message something like this. The reason that Git is installed in your terminal is because it's kind of the de facto interaction method for developers all around the world. Could you repeat what we have to set up? Feel free to go ahead and check out the hack pack. We're moving a little bit forward in the workshop. There's 3 things you need to have though. You need to have a terminal with Git installed. In essence, if you're on Windows, you can open up command prompt. If you're on Windows or if you're on Mac, you can go ahead and open up terminal. The terminal is just a simple little interaction window that you can use to run simple commands. Commands are literally just interactions that you can have with your computer. In this case, the mkdir command creates a folder. In this case, because the first argument that we've supplied to it is hello world, we've created a folder called hello world. The cd command runs something called change directory. That allows you to move between different folders. And finally, the git command. This is the one that we're going to be learning about in today's workshop. Git init initializes a folder, or a directory as we like to call it, using the Git protocol. It allows you to track a bunch of different, changes between different times. As soon as you've gotten all of this set up, we can head back to our regular slideshow. I'm going to go ahead and check out some questions. And it looks like we're good to go. Just make sure you run git init. As soon as we've done all of that, we're finally ready to start learning about what Git actually is. This diagram is the one thing that we'll be seeing throughout this workshop, or at least this chapter, and it kind of represents what the default Git repository looks like. There's 2 different things that you should really take note of here, a bunch of different circles and 2 different branches, if you will. Every single one of these circles represents something called a commit. I said before that Git is a version control system manager. I'm using a bunch of different terms here. These are all things that you'll hear on a day-to-day basis if you're becoming a Git expert. A commit is essentially a snapshot of your file system at a single point in time. As you start to change around a bunch of different files, Git will actually store different versions of those files over time. But it doesn't do it every single time you save. Imagine if you save a bad piece of code. Imagine if you are working on a blockchain and you leave a security bug inside. If you held that piece of code in a snapshot in time, never to be changed again, your blockchain wouldn't be incredibly secure. Git commits need to be extremely explicit. They don't interact, or you can't create commits as soon as you save, but you need to run a special command for you to do so. After all, a Git commit is it is quite heavy. It needs to keep track of a bunch of different files for it to actually work. We'll get into branches a little bit later on. But right now, let's explore what creating a Git commit actually looks like. I'm going to head back over to my terminal. Let's go ahead and create a file called readme.md. As soon as we've done this, in my terminal, because I'm running a different kind of shell, I can see that the branch that I'm working on right now, called master, has changed. Don't worry about what this means right now. But just to see that Git is actually tracking the changes in this repository, go ahead and run git status. Git status tells us how many commits we have, the untracked files, and what files we have in our staging area. Don't worry about what those terms mean. I'll explain them in a second. In essence, though, we can see that readme.md has been added to the untracked files area. This means that Git isn't actively tracking the changes in this file, but it knows that it exists now. Nothing has been added to our commit. This means that we don't actually know what changes we want to put in this initial snapshot. There's two different things that you need to know about Git here. There are untracked files and there's the staging area. Untracked files are files that Git knows exist, but that it isn't tracking. The staging area is something where we can tell Git what files we want to include in a specific snapshot. Let's say that you have a bunch of different changes all at once. You have 50 new files. Not every single one of those files is going to correspond with a specific feature. In a single Git commit, you might not want to have 15 different features all encapsulated. You might want to split it up into 5 different commits, every single one of which includes 3 new files for a specific feature. In this case, you might want to add every single one of the files that corresponds with a specific feature to your staging area. The staging area is the Git equivalent of a place where you can track all the different changes. To add readme.md to our staging area, to let Git know that we want the changes that have been included in readme.md to be committed in our next snapshot, we can go ahead and run git add readme.md. A shorthand for this, if you want to commit all, or if you want to add every single file in the current directory to your staging area, can be git add space dot. Now, let's go ahead and run git status to figure out if we've actually added readme.md to our staging area. We can see that we have. We can see that readme.md is now listed under the files called changes to be committed. This means that Git is actively tracking this file and it knows what changes have been made within this specific file. Let's go ahead and start to create the snapshot for it. To do this, we can run git commit flag m, and we can say readme init. Just make sure you do quotes. I'm going to go ahead and demonstrate what this looks like if you don't do any quotes and if you don't include the -m. If you run git commit, the default text editor is going to open up and you can include your commit message. This is a little bit complex though, so I'll be skipping over that kind of shorthand for now. Git commit flag m basically includes what's known as a git commit message. Every commit has 2 different things that the developer can customize. It has a commit title and it has a commit message. Each one of these should be basic descriptions of what your commit is actually doing. In this case, we can say that we're initializing a new repository. As soon as we do that, you should get something like this popping up. You can see that we've changed one file with 0 insertions and 0 deletions, and that this is the root commit. This is the very first thing that we'll be creating. Let's go ahead and edit this. I'm going to go ahead and use the echo command to add in some text to readme.md. Now, this terminal is pretty large, so don't worry if you can't follow along all at once. There's going to be a log that's posted to the Discord afterwards. As soon as we do this, we can see that master is what's known as dirty again. There are some changes that are waiting to be committed. And we can see that once more when we run git status. Let's go ahead and run git add dot, the shorthand that I talked about earlier, to add readme.md to our staging area. We can see that this has actually happened by running git status. And we can run git commit -m readme updates to go for it. Now, commits aren't the only valuable thing about Git. It also includes something known as branches. Branches can be thought of as independent lines of development, things that kind of alternate timelines for how your code evolves. Your main branch, which is the default one that you'll be working in, is your central point of truth for every single file that you create. Let's say that you're working on a server project. In your main branch, you might include everything from server setup to infrastructure to build settings, and your source code, obviously. It is the one thing that you never want to mess with. Every single commit that you make on main, every single snapshot, every single timeline update that you make will be the default for the rest of time. Every single commit that you make on main, then obviously, has to be viable and bug-free. But let's say that you're working on a piece of code that you don't know is correct. Let's say that you're working on a super volatile feature. In this case, you need an alternate development environment, something that's identical to the main branch, but something where you can still mess around with it a little bit. something that won't completely corrupt your entire repository if things go wrong. That's exactly where branches come in. Now, you can call this other type of branch whatever you want. I like to call these feature branches because features are places where you can really mess up. And you can think of this as a volatile testing sandbox. You can see over here that in our Git timeline, the sum or the set of every single commit that's been created in this repository, you can go ahead and create a new Git branch. In this case, we've created a Git branch from our first commit on main. That means that every commit that has been made on main from this point, from before this point on, will be included in feature. And we've included a couple of other side commits. These aren't going to be included on main themselves, but they're included on our feature branch. Let's go ahead and test out how this might work. I'm going to go ahead and create a branch called feat/readme update. We won't get any feedback that this has actually occurred, but let's go ahead and check out this branch. Let's go ahead and switch to it from our main branch. As soon as we've done that, we can see that Git gives us a little bit of feedback. We're now on the feat/readme update branch. Every single commit that we make here won't actually affect the main timeline on our main branch. You can go ahead and run something like iWorld. Go ahead and add this to your staging area and go ahead and commit this. To see if the update that we just created and snapshotted on the Git timeline has been committed to main as well, we can go ahead and run git checkout. On specific versions of Git, your main branch might not actually be master. It might be main. Let's go ahead and figure out the content of readme.md to figure out if we've actually done this correctly. In this case, the value of readme.md on our main branch is still hello there. It isn't high as we just committed on feat/readme update. This means that our branches or that Git's branching system is working perfectly. Sometimes though, you don't want to have two different versions. Sometimes you might want to move all the changes from one branch onto another. Someone just asked a question about rebasing. We won't be going into that just yet. This is an intro workshop after all. I'll be touching on that afterwards though. In some cases, whenever you want to have a commit moved over to your main branch, you can use something known as a merge commit. Merge commit is literally just a commit that takes all the changes and moves them from branch to branch. Let's go ahead and check out our feature branch once more. As soon as this is done, run ls to make sure that we actually still have all the proper files. We can run git status to see that there aren't any more files to commit. Let's check out our main branch once more. So perform the merge. Go ahead and run git merge feat/readme-update. As soon as we've done that, Git performs what's known as fast forward. That means that it travels through every single commit that's been created, and it, in essence, brings all the commits and changes over to the main timeline. To see that this has actually occurred, we can run cat readme.md, and we can see that instead of having hello world like it did before on our main branch, it just says hi world. And that was pretty much all that you need to know about the basics of Git. Let's review a little bit. And there's going to be two different ways that you're going to be exploring these key features in the rest of this workshop. So don't worry if none of this is really clicking right now. We just touched on what SCM and what open source software really means and what they are. We touched on what Git and GitHub are, why they exist, and how they tie into regular development. And we touched on some key Git concepts. And for those of you that have never used the terminal before, we've used that as well. We just learned about commits, branches, we learned about naming conventions, we learned about merging, and we learned about the Git tree. And we also ran through all of the key Git commands that you'll need over the next couple of days as you guys start to build out your couple. Oops, sorry, somebody just came up with a question. That is great. Just for clarity, if there are multiple feature branches that have different changes, how can you merge both of them to the main branch? Won't that cause conflicts? Indeed it will, and that's something that Git has actually prepared for. If you merge two different files that kind of modify the exact same lines, Git will actually create something called a merge conflict. A merge conflict is in essence a place where Git doesn't actually know which change to include over another. And there are some pretty powerful tools for managing those. It's pretty easy though. The only thing that you really need to know right now is that whenever a merge conflict does occur, you'll have three different options. You can either include the incoming change, you can include the regular one, or you can include a different type of change. Maybe if we have time at the end, I'll be able to demo that for you. But for now, let's just keep moving on. Thank you so much, Anonymous. And before all of that, before we move over, sorry, let's go ahead and take another super quick question break. We'll be back in about a minute. Someone asked a question, for platforms like GitHub and GitLab, was it possible to work on code with others the way we do now? That is a good question. Git was not the very first source control provider. It was actually created by Linus Torvalds when he was writing Linux, or the Linux kernel, I should say. And so, yeah, it totally was. I don't know the exact timeline, but there were definitely Git-like projects out there. A couple of other ones that you may want to look at are things like Mercurial and SVN. Git is obviously the premier source control management software out there right now. But yeah, all of this was done by hosting your own servers with those types of pieces of software. Before platforms like GitHub and GitLab came along, though, it was really, really difficult to do that. Source control was still one of the quote-unquote unsolved problems. And so as soon as it was launched, I believe in 2008, it kind of rocked the software engineering world. So yeah, TLDR, it was possible to work on code with others before GitHub and GitLab. It was just really, really difficult to. And so it looks like all of those are, and so yeah, it looks like all of those are all the questions that we can answer right now. There are a couple of others in the stream. Feel free to open up the Slido and put in some more. We'll be answering all of the longer questions towards the end though. Thank you guys so much. And now let's run through exactly what GitHub is. Like I said before, GitHub really rocked the world of software engineering because it made it so easy to share your code and Git repositories with other people. You can think of it like hosted Git. It's the home of open source software, and creating a GitHub account creates a whole new world for you to explore. And it's the one key tool that we need to unlock the true collaborative features of Git. Now, there are other platforms like GitHub, like GitLab, that do a pretty similar thing, but GitHub is still the premier service for doing something like this. The first thing that we'll be doing is exploring a real-world repository. In this case, we're going to be using, or we're going to be starting to work around a little React library called Jotai. It was created by the Floymandris organization, and I'll give you guys a couple seconds to open this one up. Don't worry if you don't actually know React. We won't be doing anything super interesting with it. We'll just be modifying a couple source files, just so that you guys can really understand what the Git workflow looks like with GitHub. All right, sweet. As soon as this happens, we can move on over and check out what Jotai looks like. There's a couple of really key features that that we're going to be looking at in the next big section. In essence, Jotai is a tiny little state management library for React. As I said before, don't worry if you don't know React or JavaScript. That's totally okay. We're literally just going to be modifying a couple of different lines. Feel free to look through this. It's actually a pretty interesting library, but there's a couple of other ideas that I wanted to draw your attention to. When we're learning about Git and GitHub, it isn't just because they're really, really cool tools for project management and for collaboration. GitHub also allows you to become an open source developer in a snap. When you're on this website, go ahead and take a look at contributing.md. Pretty much every single big GitHub, pretty much every single big GitHub, every single big GitHub project will have something like this. A contributing.md file allows you to invite other open source developers to figure out how they can add more and different features to your own project or repository using the tools of Git. Feel free to explore the rest of this repository at your leisure. Go ahead, and run through some of the other features that GitHub has. Issues are a really popular one. You can think of issues like Slack, Stack Overflow, and Reddit all combined into one. We can go ahead and open up any random issue. Feel free to click on the Issues tab and open up a random issue to figure out what an issue actually looks like. I'm not currently signed in, so as soon as we finish wrapping up these first couple of issues, I'm going to go ahead and switch on over to Safari. That is another good question. The young grandpa asks, what is forking? We're actually going to be covering that in this chapter. Feel free to sign in on GitHub to get yourself prepared for the next couple things. In essence, issues allow you to collaborate and chat with other developers. They're meant to connect people over ideas. Every issue also includes something called a thread. Each issue is atomic. You can't blend two different topics together in one specific issue. Every single time you want to add on an idea to an issue, you can add a reply. I'm not signed in right now. Yep. Sorry, hopefully that's a little bit better to see. As soon as you want to add in a new idea to the issue thread, you can go ahead and click respond. Obviously, like I said before, I'm not signed in on this specific instance of my browser, but feel free to mess around with some of the reply features. Don't actually reply. You don't want to get yourself banned for contributing to Jotai, but TLDR, that's what an issue actually is. Issues are also a really great way to get in touch with new people. If you've discovered a new project and you want to contribute to it, issues are the place for you. If you have a GitHub account, you can go ahead and respond, hey, I'm so-and-so. Here's what I want to work on, and here's why I want to do it. As soon as that happens, you'll be free to work on this one random feature in a whole different project. Obviously, being an open source developer is a little bit difficult, but that's a conversation for later. Open source is an incredible movement, though. I highly recommend you try it. And now it's time to get into forking. I'm going to take a really quick pause right now as I get my GitHub instance set up. I'll see you guys in about 2 minutes. Thank you guys so much. The young grandpa just asked another question. How do we use a Linux terminal while on a Windows computer? My computer defaults to using PowerShell. Do I have to use WSL? That's a really good question. You can if you want. Git actually works cross-platform, so you don't need to use like a Unix-based operating system to use Git. If you're more comfortable using something like Bash, though, feel free to. I find that the Windows subsystem for Linux is a little bit buggy, but if it's useful for you, go for it. All right, let's get back to it. Let's say that we have a repository that we want to contribute to. We've added a comment in. How do we actually go about contributing to it? How do we add our own changes, and how do we bring it back into the main repository? That's exactly where the concept of forking comes in. And thank you so much to the young grandpa again for asking that a little bit earlier. A fork is a special kind of branch. Obviously, for massive open source projects, you can't just have everybody contribute to the same main branch. That would be incredibly hectic, right? What happens if somebody deletes the entire project? It's gone forever. Well, a fork is a special kind of branch, like I said before. It gives us access to writing on our own copy of the repository. Like I said before, a branch is in and of itself a complete timeline duplicate of the main branch. In essence, a fork takes a repository and brings it on over to our own GitHub account. It's literally just a branch, but with extra features. It's important to note, though, that forks don't have access to issues. They're a feature made specifically to contribute back to an existing repository. Let's go ahead and figure out how forking works in this specific case. I'm on the Poimandres Jota repo, excuse me, and I'm going to go ahead and fork it over to my own GitHub user account. It's going to take a couple of seconds. And to Kushan, who asks, what shell are you using? I'm using the fish shell. I used to use the Z shell for quite a bit. macOS Catalina actually comes with it installed by default. I just find that fish is a little bit easier for me to use and configure. Now, I've just created my own fork. As you can see over here, I completely own this repository. You can see the settings tab. I can do whatever I want with it. Let's go ahead and make some edits right here in GitHub itself. Go ahead and scroll down to readme.md and click on this little pencil icon as soon as you've created a fork. I'm going to go ahead and do that right now. And you should see a bunch of different code appear. I'm just going to add in a bunch of different gibberish. Now, this actually isn't super great. For Arhum, that's another great question. On the Jotai repo, I'm going to put that in the chat right now. On the Jotai repo, go ahead and click on the fork button in the top right-hand corner. Now, I'm going to get back to editing this. This is a lot of gibberish. It actually isn't something that should go into any repository whatsoever. Jotai is a massive library. It has thousands of different stars. So obviously things would go really wrong if I committed this onto my main branch, right? Well, I'm actually going to go ahead and do just that, just to show that forking actually works. Down here, you can see that GitHub automatically commits all the changes that we make. I'm going to commit this directly to the main branch, though. As soon as we do this, we can see that my little gibberish appears right there, right where we placed it. But if we go back to the regular Jotai repo, we can see that nothing's changed. That is the beauty of forking. It allows us to make whatever changes we want on our own machines and on our own accounts without disrupting the development flow for other repositories. Now, after all of that, it makes sense that open source contributing is pretty easy, but we can't use IDEs in GitHub. It's literally just a web application. If you're working on a massive Python project, you can't just edit file by file. You need a bunch of different tools for that. And like I just demonstrated, you can edit directly in the site, but it is incredibly unwieldy. How do we bring this Git repository onto our own machine? Well, for this, you can use the git clone command. I'm going to go ahead and do that right now. I'm on my fork right now. I'm going to go ahead and click on this little green button called code. You should see over here under local, a tab called clone should pop up, along with an HTTPS, a little URL, and a clipboard right beside it. Go ahead and click on that clipboard to copy it to your clipboard. I'm going to head back out of that specific directory and into my base one. And I'm going to go ahead and run git clone and then copy and then paste in the URL that we just got. As soon as we do that, it's going to do what's known as a clone. As soon as I run cd jotai, like I said before, the cd command changes directories. Anonymous asks, is forking the same as cloning? It is not. Forking is a special type of branch creation. From a regular repository, a fork is a different type of branch that brings that repository, or a copy of it rather, into your own account. It allows you to edit whatever files you want without disrupting the main branch. Cloning, on the other hand, brings a repository from GitHub to your own computer. In the initial diagram that I showed you, where GitHub was at the center and there were a bunch of different developers all around, the process of taking GitHub's code and bringing it onto your local machine is what's known as cloning. We can see over here by running ls that all the files that were in the Jotai repository on GitHub are now on my own machine. And we can see by running git status that this is indeed a Git repository. We run cat readme.md to figure out if this is the actual Jotai repository or my own. We can go ahead and run cat. In this case, we can see that my random little gibberish actually shows up. This is my own version of Jotai. Let's go ahead and create some edits. I'm going to go ahead and open Vim, and let's open readme.md once more. I'm going to go ahead and change around some more gibberish in the readme.md. What's the point of forking when you can clone? That's another really great question by Kashan. Thank you so much. Now, let's say that you're working on a massive project, something like React, right? Something that has tens of thousands of stars that is depended on by tens of millions of projects around the world. If you had read and write access on that, on that specific repository, the actual main React repository, things would go wrong really, really quickly. Anybody in the world could delete that entire repository, could make edits to the branch timelines, could change around files so that nothing worked, could introduce security bugs. That isn't really great for anybody involved. And so whenever we want to make edits to a public repository, we have to use something called forking. We have to take that repository, make a branch of it, and bring it on over to our own account so that we can edit it freely without disrupting the main development flow. Cloning, on the other hand, takes a regular repository, even if it's a fork, and brings it down to our own specific laptop or computer. Thank you so much for that question, Krishan. That's a really important distinction to have. Anyways, I'm going to go ahead and make some more edits. Let's replace the initial tagline with something like "Hello World." This is at the north. As soon as we do that, I'm going to go ahead and run :wq. If you're in Vim, or if you don't know what that means, this is literally just the command that you can use within Vim in normal mode to exit and write a specific file. As soon as we do that, we can see that on our main branch, which in this case is main, not master, now has some dirty, is now dirty. I can run git status to figure out what specific changes I've made and what things I need to add to my staging area. Does the change in the main branch reflect your fork? It does not. Your main branch and your fork are two completely separate timelines. I'm going to get to merging and figuring out what pull requests are right after this. That's another great question, Kashan. And that goes for the young grandpa as well. Once we forked and made changes, if we wanted to now contribute that change in our feature to the original library, how would we do so? Both of these things are really important questions, and you can do them using something called a pull request, which is what I'll get to next. I'm going to go ahead and commit my changes to this just to demonstrate how that actually works. I'm going to go ahead and run through the exact same protocol that we've done once before. Go ahead and run git add doc and git commit -m. Let's just name this stuff. This is all just like a testing repository anyways. And so as soon as this happens, we can run git status, and we can see that there's nothing to commit, and our working tree is clean. There's one last big thing on like the local GitHub commit and development cycle that you really need to know about, which is pushing. Now, if you have a local version of a specific repository, how do you take that repository and then push it out to GitHub servers? This is exactly where pushing comes in. If we go ahead and go back to your fork version of Jotai, reload, you'll see that the changes that I made locally, which literally just replace this specific tagline, don't actually show up on GitHub. This is because I made the commit locally. I now need to take these changes and push them off to GitHub. I can do that by running git push. As soon as that happens, we can see that Git has counted all of my objects, it's performed compression, it's written all of these objects, and it's resolved all the different changes, and it's pushed these changes to my local fork of Jotai. And now, if we reload, we can see that the tagline has changed. All of my changes have been committed from locally to my remote. And that brings me to the final stage of the GitHub development cycle, the pull request. This is the one really massive thing that kind of clogs up everybody in like the development cycle. Pull requests are probably the most important part of GitHub and open source development right after the commit. As soon as you've selected your issue, made your contribution in a specific branch, and remember, this branch may be a fork, I said earlier to read through the contributing.md file if you're ever looking to become an open source contributor. Make sure you have that read through so that you're following a repository guidelines for creating new files or features. You can open what's known as a pull request. Pull requests are essentially just threads that include a merge, like kind of a merge proposal that allows you to discuss with the open source repositories maintainers about specific changes that you made. How does this implementation work? What changes have you actually made? This is like the code review stage. If any of you have worked professionally in a software engineering environment, code review is actually where, pull requests are actually where code review might happen. Maintainers and collaborators can add comments to your changes and talk through threads and possible improvements. Let's go ahead and take a look at what some of Jotai's pull requests might look like. Go ahead and open up Jotai once more and click on pull requests. There's 3 open right now. Let's go ahead and check out this one, fix query refetch. There's a couple of different comments here already. We can see that there's a couple of different bots that are helping out. There's Vercel, there's Code Sandbox, and there's a couple of other people that added comments on this person's changes. The whole point of pull requests are right here. We can see all the different commits that someone's made in this specific branch that wants to take it from this specific branch and merge them into main. This is exactly where your contributions actually go and get committed to the regular repository, right? Sometimes your pull requests might get rejected. Sometimes your contributions aren't valid, and that's perfectly okay. You can chat with them in this specific pull request thread, and you can edit your contributions to make sure that they're actually conforming to standards. In this case, let's go ahead and not actually create a pull request. Let's go ahead and figure out how, what the flow might actually look like. I'm going to go ahead and click on the open pull request button. And now we can hit create pull request. Don't actually hit create pull request as soon as this modal pops up. We're just looking through what it looks like. In my title, I'm going to say update tagline. And every single pull request, every single issue, and every single comment can all be formatted with Markdown and has file support. I'm going to go ahead and say, I'm doing a workshop for North 2021. Now, if this was actually a legitimate change, I'd hit create pull request right here if I was fixing a bug or I had permission to work on a specific issue, but I don't. And you don't either. So make sure you don't click that button. But that's exactly how a pull request might work. And in a similar way, you can merge the main branch of a regular repository in with your fork to make sure that both timelines are exactly correct. Thank you so much to the young grandpa and Kashan for asking those questions. Let's go ahead and go back to our presentation. And it's time for another question break. Now that you've learned about all the basics of Git and GitHub, you've learned about everything from what a commit is, what a branch is, all the basics of Git and software engineering, to figuring out what a pull request is and how to merge branches. You've come so far already. Feel free to ask any more questions in Slido. I'll take a couple of minutes right now. Do you have time for merge conflict resolution? Let's check it out. We are running a little bit low on time. I'll just quickly speed through this next little section, and we can start experimenting with that. We're actually going to run through a couple of merge conflicts right in this next section. So yeah, we'll almost definitely have time for that. Thank you so much for asking. Can the project maintainers tell when someone makes a fork, branch, clone, etc.? Indeed, they can. Yeah, that's pretty much the entire point of what open source does. Being able to tell when someone creates a fork, a branch, or a clone, not a clone per se, basically allows you to keep track of how a bunch of different developers are using and contributing to your project. Clones are actually a they're actually a stateless operation, so you can't tell when someone's cloned it. You can tell when somebody's pushed, though. Whenever somebody creates a fork, you'll actually see an increment counter. If you go over to your Jotai repository, let me just head back over real quick. If you head back over to your Jotai repository, you can see that 138 people have forked. These are all of your basic stats. Yeah, whenever somebody creates a branch, you can just check it out in their fork. All right, sweet. Let's zoom through this final section. This is probably going to be my favorite. One last question. So the pull request on fork project goes directly to the source repository. Yes, you can't create a merge commit from two completely separate timelines. That just doesn't make sense. It's like if I wanted to create a character in Harry Potter and bring it over to Percy Jackson. They're just fundamentally incompatible. They're two completely separate timelines. Yeah. And now let's head back to the final section, your very first contribution. For all that though, let's recap once more on all the things that we've learned so far. Right now, we've learned all the basics of Git. We've learned about committing, branching, merging, what the Git flow looks like, and timelines. We've learned about what issues and pull requests are, and how forking works, and how to generate them, add new commits, and push them. And we've learned about what clones are. We've also learned about a couple of open source files. Contributing.md is the really most important one. I've included a couple other ones right here for you to, play around with. And we've learned about the abstractions and the theory behind what Git actually looks like. We've learned about what source control is and why it's needed and how to use it. And we've also learned about the contribution workflow. We've learned about quickly looking through a repository to figure out how you should act and what the repository's conventions are. We've learned about how to create an issue and how to tackle an existing one and how to really just act nice in a repository environment. We've learned about how to fork a repository and create a pull request, how to clone it and push it back up again, how to structure your changes and bring it back home to the regular repository. And we've learned how to create a pull request. We've learned how to discuss and check in on our regular changes to pass, reiterate, and discuss with maintainers. And this is the final project. We're actually going to be creating a little list of profiles for everybody here. I built this a little while ago for one of my previous workshops at Hack the North. This one was made for the open source workshop. It was built on Next.js, deployed through Vercel, and uses GitHub Actions for checks and CI/CD. Don't worry if you don't know what those last couple of terms meant. It's all good. I'm going to go ahead and paste in the URL for this in the chat. You should also have it somewhere in your hack pack. As soon as you have this repository open, we can get into your task. It's actually really simple. I just showed you how to fork a project, how to fork a project, how to clone it onto your own local repository or onto your own local machine, and how to really just add new things to a remote project. And your task right now is to add yourself to the list according to the conventions laid out in the repository. Let's see a little bit more on what that actually means. In ratiosource/OSS, there's one file that you need to edit. That's profiles.json. This is just one specific large JSON file that holds a couple of different elements. Every single one of these is a profile that gets compiled, into an actual Next.js website. Go ahead and check out oss.rishi.tx to see a demonstration of what this looks like. And for the person that was asking about how merge conflicts are resolved, we can actually check out how this works. I'm going to go ahead and merge in, let me open this up on my other browser. I'm going to go ahead and open up a pull request that somebody made a little while ago that updates a specific couple of lines. Let's see this one. The green check mark simply means that that all checks have passed. And when it's checking for its ability to merge, automatically, in essence, what Git is looking for is whether or not it can automatically merge. All of this is slightly advanced Git territory, so don't worry if you aren't understanding this. Let's go ahead and click Resolve Conflicts. And yes, it is Opera GX. It actually has some pretty interesting performance implications. I tend to use Safari for my day-to-day browsing though. But for the person that was asking about how to resolve merge conflicts, if your merge conflict is really simple, you can actually just edit the merge right here. You can check out what lines are conflicting with others. In this case, we have two different changes that are conflicting. There are three different people that exist on the exact same lines. It looks like a couple of people basically just created the exact same, created the exact same JSON object on the same lines. So when you merge, Git doesn't know which should take precedence. I'm going to go ahead and remove some of these other weird lines that Git adds. I'm going to go ahead and insert valid JSON. I'm not doing anything super interesting right now. In essence, just so that the user actually knows that there is a merge conflict, Git introduces three different lines. It introduces a little start line, it introduces a middle line, and it introduces an end line. Every single one of these allows you to figure out where the merge is and how it works. And so now that this is valid JSON again, I'm going to go ahead, scroll down, or scroll back up again, and hit mark as resolved. And as soon as that happens, we can click commit merge. And as soon as that happens, we've resolved this commit, and I can go ahead and merge it. Now, as soon as that happens, we are all good to go. That's exactly how fixing a merge conflict works. Now, I see that a lot of you are starting to put your pull requests in. That's amazing. I'll be resolving all of them right after this workshop. We're running a little bit low on time. Here's a couple of links that you'll need. Obviously, all of these were posted in the YouTube and Hopin chat as well. Don't worry, you can always refer back to those. And with that, we're finally at the end of this workshop. I can't believe it. Time flew by. As always, I'm Rishi Kotari. You can reach me at Rishiosor at most platforms. I'll be hanging out on the Hack the North Discord at Rishi #7757. And you can email me at any time at hey@rishi.cx. Now's the time for any questions that you might have. There's a couple that we've been holding off on. Rishi NFT when? One of my friends sent that. I'm a pretty big blockchain nerd. I'm not really planning on minting an NFT of mine anytime soon. Could be interesting though. Might be in the works. What inspired you to start programming at such a young age? When I was 8, my family went over to another family friend's house for literally just like a regular family reunion. I was really bored. I started rooting around in the utensils and stuff. And eventually someone started yelling at me because an 8-year-old kid rooting around in the utensil cabinet, it kind of poses a safety hazard. So after I got told off, I just started roaming around the house. Eventually I found this one random room. Someone was on their laptop and there was a bunch of really interesting flashing colors on it. I was really interested in it. And so, at the end of it all, I just asked him what he was doing. And that day we set up my very, very first website. And ever since then, I've kind of just been snowballing. A couple years later, I discovered GitHub. I got banned from it when I was 11 after Hacktoberfest. And when I was 13, I finally got back to open source contributing again. Programming has been a pretty incredible part of my life. It's taught me so much about the kind of person that I want to be. It's taught me how to write well in a really weird way. And it's honestly just taught me so much about what logical thinking actually looks like. What even is blockchain and how does it work? I think there's a lot of ways of explaining blockchain. For me though, I think blockchain is literally just, you can basically think of it like Postgres or any regular database, but instead of having it centralized on one specific computer and have admin access, it's distributed over a bunch of different nodes. Blockchain works by using hashing blockchain works by using something called a consensus protocol. Basically, every single time you want to update the data stored on a blockchain, any single one of the nodes that has a blockchain running on it can basically ping the network. Every other node or a specific select few might say, okay, here, here's a new update. I'm going to take this in and I'm going to see if this actually works. On blockchains like Bitcoin, they use a consensus protocol called proof of work. TLDR, a blockchain functions by having a bunch of different people all coincide and agree on what correct data looks like. As soon as a specific piece of data is valued as correct, it gets copied and sent all across the network. So you now have thousands of different nodes that all have the exact same piece of data. Blockchain is just a glorified database. And it looks like we have time for maybe 2 or 3 more questions. Feel free to keep them coming. How do I get my changes onto a branch or project again? Go ahead and go back to your fork. You should see a little bar that has a pull request icon on it. As soon as you click that, a new modal should open up, allowing you to merge your changes, create a pull request into my project. All right, sweet. It looks like those are, I had another question. It was too long for Slido. I added it in my pull request. Could you check it out? Yeah, totally. I'm gonna open that real quick. Oh, it doesn't look like you've commented your question yet. All right. Oh, I see. I think it'd be neat if we could be informed of workshop prereqs for the rest of the workshops in Gear Up. Yeah, totally. Yeah, every single workshop in Gear Up actually has an announcement tied to it in Discord alongside the hack packs and the prerequisites. So yeah, that's totally okay. Thank you so much for the feedback. And after all of that, it looks like we're finally at the end. Thank you guys so much once again for having me. I'm Rishi Kotari. And yeah, I'll see you guys later in Discord. Thank you so much.